Did you know AI systems like Google Bard, ChatGPT that work on large language models, aka LLMs, are hosted on high-performance compute systems from public cloud service providers like AWS? Wait, does that mean all the attacks that are possible on public cloud services like AWS are also applicable to attacking LLM systems like ChatGPT and Bard?
Oh, that's probably true.
Well, what about open source libraries that are used by these software systems to give you the perfect answer for tell me a story of aliens in the style of Shakespeare?
Who really wrote the plays of Shakespeare?
Or making AI avatars of yourself to know what kind of suit would look really good on you? Turns out the answer is yes, and in this video we'll talk about the different kinds of attacks that you can have on large language models used by systems like ChatGPT, Google Bard, and others that may be coming in the pipeline.
AI, Generative AI.
Alright, I'm getting into it. In case you don't know what LLMs are, this is the 10-second version for LLM is. LLM is not a legal degree, which is what you see when you try and Google LLM. Instead, it is a massive database of different types of data, which could be text, your images, or anything else which you may want the AI system to consume the data that is in the LLM and give you information based on a human response that is provided by you. Essentially, you put in a prompt and based on the data it has consumed, the large language model would help it decide, oh, this is the response for what kind of suit looks good on Ashish. All right, let's talk about the LLM attacks now. There are 4 broad categories that you can define most of the LLM attacks on, and I'll leave a link to the references that I've used in the research on the description. And I'll give you some resources towards the end as well that you can use as a way to go on further reading. The first category of attacks that is possible on LLM systems is the LLM application input or prompts. Essentially, LLM systems like ChatGPT, Google Bard are an amplified version of a chatbot. The way they work is you as a human would give it prompts and it's supposed to give you a response based on the data that it has consumed and the question that has been asked as well. So using that as a reference, it's supposed to give you a response. Now, what happens if you are able to do prompt injection and make it say things that it should not, like maybe able to go beyond what the boundaries are set. Now, typically when you try and ask ChatGPT or Google Bard anything nefarious, it would usually stop and say, hey, you should not be doing this and I'm not designed to respond to these questions. However, in this scenario, if you are able to just do the right kind of massaging to your natural language prompts, you should be able to go around this, and it's a very possible likely attack that has been seen by some people. If you Google enough, you'll probably find those prompts as well, where you're able to trick the system into giving responses that they're designed not to give.
No ideas, no rules, no management.
The second kind of attack that can happen under this category is unauthorized code execution. Essentially, you're using natural language to generate code. You're also using natural language to create phishing emails and a lot more. The simple thing is, if you're able to type in a natural language and you're able to give it a code as an input, and if those inputs are not sanitized properly, what happens if that code is executed on the system itself and gives you an input or something sensitive comes out? Talking about something sensitive, this leads me to the second category of attack, which is data used by the LLM application itself. Now, these things could include data leakage, essentially things like, hey, I put in a prompt but gives me information of AI Ashish, or hey, I put in a prompt and gives me information of Shilpi, who's the producer of the podcast, instead of giving me a response for the question that I asked. Or even worse, it finds the competitor of my company and gives me information about them for whatever thing that they had put into the learning model. Another part you could also do is data poisoning attack. Data poisoning attack is on the data that is being used by the LLM model to train itself. You could introduce backdoors or vulnerabilities through the training data itself, which is called the data poisoning attack. The next form of attack is the training data leakage. What happens if the data that you've used for training gets leaked in front of the human that's asking the prompts or the questions, that you get to know, oh, what kind of data is actually being used? Because technically at the moment, we don't really know where the data is coming from for ChatGPT and Google Bard and all of that. We don't really know what kind of data have they used to train the LLM behind the scene.
I know Kung Fu.
But imagine if that data is leaked at some instances, which happened with ChatGPT, where there was a vulnerability that they found, which I'm going to talk about a bit later as well, but that vulnerability allowed me to see the history of another user of ChatGPT. That's a bad thing, isn't it? Which leads me to the next attack, backdoor attacks or the Trojan AI attacks. Basically, the model itself could be corrupted in a way that you can leave backdoors to come back and modify the model. So if you put certain kind of prompts, kind of like what happens when you play GTA 4 and you hack the system in a way that you have a special hack to get a special skin or a special gun in Call of Duty, depending on which kind of game you're into, it is kind of like the same thing. The backdoor attack and a Trojan AI attack could literally be in the form of a special prompt that you put in because you know what the model was and you know what the data was in the background. So you use that prompt to enter into a secret mode and you basically get access to a lot more information. Now that is also an attack which is possible from the data, potentially from people who are building the application itself. Talking about building the application leads me to the third category, which is the LLM application itself. Now the people who are building the application, I think they are obviously in the core, they are like the super users, for lack of a better word, onto the LLM systems, and they could introduce vulnerabilities into the application itself. Now some of the common examples that you would see for vulnerability is SSRF vulnerability. SSRF vulnerability could result in giving inappropriate access to people, where it exposes a potential internal system onto the internet or onto an attacker of the system, whether it's access to the API which is internal to the system, or whether it's an application that is internal and is probably the core engine that helps you get the answer for the prompt that you put in. Another form to this could also be the open source library vulnerability or supply chain vulnerability, because how can you forget supply chain in this? This is also the reason for the outage that ChatGPT went through in March. And what essentially happened was they were using Redis, which is an open source, for caching information. And that's how they were leaking, unfortunately, the information of another user. Say, I'm asking a question and I see your information as my response. That's pretty much what was going on. Now, to extend that example a bit more, how many more open source libraries are being used within the application? And I think the stat is 95% of the software that is used by most people or built by most companies has open source in there.
Wait, you used open source code in my billion-dollar prototype?
So you can infer from that there would be a lot more open source vulnerabilities that the application may itself be vulnerable to. Then the other one is identity and access management itself. We mentioned about super users who have access to the LLM application itself. And the two categories that I spoke about so far, the data itself or the input prompt. Now you as a person who has access to these systems potentially are running this on a public cloud service provider. We already know how complex identity and access management for applications in general is. And then there is a whole layer of doing application security for the application that is the LLM model, or at least inferring from the LLM model. Then there is the API that is allowing information to be brought to the user. And today OpenAI has also got an API or an application programmable interface that allows you to interact with it just using command prompts. You don't even have to go onto the website. You can literally program your way and program an agent, an AI agent, for you to run queries without even going to the ChatGPT website. Now imagine this, if you put in a prompt and it shows you an error message from the system itself, unintentionally or maybe sometimes intentionally, and you get to know, oh, this is the version of the open source library that they're using, then you can use that as a model inversion attack. That's another form of attack that people talk about in this category, where you're able to use the output to get details about the internal system and use that against the system to attack it. That makes it really exciting, doesn't it? But talking about the systems itself, they're obviously hosted on an infrastructure, which could be a public cloud service like AWS. They have been talking about high performance compute for a long time, and other cloud service providers are also providing services for high performance compute. For context, high performance compute is the information that is available in petabytes and zettabytes, whatever comes after that. You need high compute capability to be able to process information, and the cloud service providers are obviously giving you that access through a click of a button, which opens this to the infrastructure attacks that are possible on the LLM, which opens my fourth category, infrastructure that is used to host the LLM application itself. Now, granted, some of them are using on-premise and some of them are using cloud, some of them using just cloud, depending on who you talk to. I think the two popular ones from Stability AI as well as from ChatGPT, of course, Google Bard is using Google Cloud. So they definitely are already using their cloud provider. We already have the top three chatbot signed as services, which is your ChatGPT, Google Bard, and if you're looking at Stability AI as well, the folks from UK, whoop whoop, Stability AI is also running on AWS. And you don't have to go far to look at the vulnerabilities that are already being announced by a lot of these cloud service providers through research that has been done by amazing researchers. I will leave a link to the GitHub repository where we've been maintaining a list of all the vulnerabilities for these cloud service providers for your pleasure to read. Talking about infrastructure, it's also worthwhile calling out there are other forms of things that can happen outside of just the cloud service provider's control. Remember shared responsibility that your cloud service provider reminds you of, that if they are taking care of the infrastructure and we are running a LLM model application like ChatGPT on the system that is provided by them, we are still responsible for the identity access management for it, the APIs that are exposed by the cloud service provider, and if we don't appropriately manage what is exposed from it, not having appropriate access to the cloud API, which exposes your internal LLM application API also to the wide world if you didn't want to do that. Inadequate sandboxing. What if there is no separation between the environments that are available for people to use? My dev, test, prod is all using the same data. There's no data sanitization or anything else. Or what if you're trying to work with multiple LLM models because you realize that actually ChatGPT version 4 is not good enough. I need ChatGPT version 5, but you didn't have proper separation between the version 4 and version 5 and kind of like mingle the two, and what you get is 4.5 I guess what you ended up with. And finally, another one is just the compute itself. Like, there could be vulnerabilities on the cloud side, on specifically the high performance compute side. And third parties are another one that you probably should look out for. There would be third parties that would be associated with your cloud service provider to help you monitor, scale, and even inform of anything which is nefarious going on right now. They all could be compromised as well, as been seen by many people in supply chain, because you could have a third party that also has access to your system. I think the best example for this was Okta. When that Okta hack happened, where there was a call center that was taking care of support tickets for Okta, the identity and access management cybersecurity company, they had a breach which resulted in having a breach at the end of the Okta. All right, worthwhile calling out, it's not just doom and gloom. There is also a responsible AI conversation to be had here. I've already spoken about the 4 different types of AI attacks, but it's also impossible to not talk about AI without talking about responsible AI as well, which is essentially not relying completely on the information that is provided by your LLM model. Because let's just be honest, they do hallucinate. They do give you misinformation. They just assume things that have happened. So not relying on the information that is provided by your ChatGPT or Google Bard is a great thing. Even they themselves ask you to not use that information as a Bible of the answer that you want. So you still need to verify the answers that you get from it. And you also need to look out for inbuilt biases that may be already present in the model so that it gives you a certain response. Now, this is not just applicable for ChatGPT and Google Bard, but any enterprise out there that is making LLM or language model for themselves internally, so they don't have to rely on ChatGPT and Google Bard. Now, as important as these attacks are, there are also ways to protect against these as well. Now, if you are from the blue team trying to see, oh, okay, so all these attacks are possible, what are some of the ways I could be defending against this? I have 3 examples for you. The first one being Attack MITRE came up with a framework called Atlas. You can see the entire trajectory of how someone gets information about your LLM model and how they would try and take over the entire system they had to. Now, there is a whole concern about the privacy as well. If you're able to remove sensitive information and keeping data privacy in mind, you're able to at least limit the exposure that training model has for some of these attacks. You can even also inverse attack this. You can also use adversarial training on your data model so that the way it responds to adversarial questions or prompts from people, it's aware of it. It does not respond in the expected way, which is kind of has been the traditional path. Like all these applications that are there out on the internet have done this for years, where you're able to train or at least have fixes for potential known attacks that are available on your system because someone was doing a bug bounty program or a pen test on the LLM model that you're running as well. Now, there are another resource that I would talk about from a risk management perspective. NIST came out with a framework on how you can do risk management for AI. Another resource which I must give a shout out to is from Daniel Miesler, who did the attack surface map version 1.0, and I'm sure many more versions would come in. And finally, for OWASP Top 10, which is working on a top 10 list for LLM models, which I'll be looking forward to contributing into as well, and maybe make a video on it from the future. I will leave a link of all of these resources in the description or in the comment below. But if all these kind of attacks are possible, how do you identify and respond to AI attacks that may be against your system? And even if you're not a LLM system, what about AI attacks against those systems? We'll cover this in the next video of our 3-part AI security series that we're running on Cloud Security Podcast. By the way, comment below, let me know if I covered everything that you would have thought or imagined from an LLM attack perspective. Would you add anything? Definitely leave a comment as well. And by the way, if you enjoy content about cloud security and AI security, because AI is hosted on cloud, so we're covering that as well, definitely check out our entire channel. We talk about cloud security all day, every day on this. And we'll also be covering AI security specifically from the cloud perspective as well. So I'll see you in the next video. But if you have any comments or thoughts on what would we cover next from an AI security perspective, definitely drop it as a comment. And I'll see you in the next video. Peace.